Okay, good morning to everyone.
Good morning, sir.
Good morning, sir.
Well, as we already discussed in the last class, things are improving at the COVID side. Government announced the complete lockdown being lifted, so no restrictions, nothing, and it's already planning to start all the colleges and all that. So most likely you will all be required to come to the school quite soon. Maybe like department might plan to conduct examinations, give more preference to complete all the examinations, including the last semester unfinished maybe end exams, labs, and all that. So we may have to plan uh, coming to the Hyderabad and all that. So get prepared accordingly. And then coming to our course now we are actually talking about socket programming or network programming, where you have to develop two programs which are called as client and server programs. And using C language, right now we are doing. Last class we already discussed about the socket programming using Unix sockets or Linux sockets, local sockets. They are also called. There are two types of sockets. Uh, using Linux sockets. The other one is actually by using network sockets, IP sockets. So local sockets or Linux sockets are useful to develop client server programs to run on the same machine. It doesn't require any network. You can run both programs on the same machine. So in such scenarios, this is going to be useful. And the other one by using the network programming or socket programming using network, or by using IP sockets, it's also called. That requires network actually. That also requires network in the sense actually your computer requires what? Like a kind of a network interface card, NIC card. The hardware required for connecting your computer to a network, that hardware is called as network interface card, NIC card. And that card may be supporting a wired network or a wireless network. Right? In case it is supporting a wired network, you require to connect your Ethernet card or Ethernet wire, right, to your computer physically. If it is a wireless one, you may have to switch it on, connect to the wireless access point and all that. I think all of you are familiar with that. So coming to the programming part, we have seen already because socket programming is a highly generic one, because of which different technologies, in case you want to use them and then develop, uh, the same system calls are actually used in spite of technologies being different. So that's why there is a necessity to develop a generic address and a specific address. So all your system calls, they require generic uh, pointer to the addresses to be passed. Whereas when you are using a specific one, you need to use a specific address structures. Specific address structures. Coming back to this particular thing now, like these are the header files that are to be included. Systypes.h, where you find a lot of types, different new types being, especially integer types and all that. That kind of thing is available in systypes. Syssocket.h contains generic system calls related to socket programming, your socket and all that. Accept, bind, things like that. stdio.h you are already aware of, printf and all that. sys/un.h contains like what it is, declarations specific to Unix sockets. Declaration specific to Unix sockets is available in sys/un.h. UN stands for Unix. UNISTD.h contains some of the uh, declarations required while writing your program. stdlib.h, maybe exit, things like that is going to be there. We have already discussed all this. We are only reviewing to complete a little bit faster. So, as you know now, struct sock addr underscore un. This is the actual structure that contains like the address to which the client would like to connect to the server. What is the server address to which the client program would like to connect? So we should be able to specify what is the server address. In the case of Unix sockets, we have to specify the file name actually. A kind of a file name is used to identify a server uniquely. To identify a server uniquely as a part of it. And the other things are there. So socket is the actual system call which returns a socket file descriptor, just like your open returns like a file descriptor. Ultimately, the network programming, especially when the communication starts, you will be using basic I/O functions like read write, so that you can read from the channel or the network, or you can write onto the channel by using read and write system calls. So socket is returning an ID, just like open returns an ID, socket file descriptor. And here socket system call, depending upon your technology and network technology, and whether it is local socket or network socket, you have to pass the appropriate parameters. So socket of AF underscore Unix. For developing Unix sockets, you have to specify AF underscore Unix. AF stands for address family, actually. Address family. AF underscore Unix, comma. And then whether it is TCP based, that is connection oriented or connectionless protocol. So if it is connection oriented, you have to specify sock stream, right? Comma. Third parameter is always going to be 0. Very rarely, you may have to specify a different value. But for all our purposes, actually it is 0. And then the second point is you have to bind your server to a known address so that client can connect. How do you specify the address? By using these structures. Address dot socket Unix. SUN stands for socket Unix. Underscore family is AF underscore Unix. And then you have to specify some file name to indicate that this server program is going to run on that. You can give any name. So in this case, it is server socket. It is a string here naturally. This file should not exist at the time of creating this. Right? So that is very important. It's going to create on its own. So strcpy on address dot sun underscore path socket Unix path. That is the path name of the file. Complete path name you have to give. When you're giving only this name like this, that means whenever you run the program, your server program, this file should be there in the same folder. This file should be saved there in the same folder. And then length equal to size of address. It is the length that determines the type of technology. That means whether you are using like a network technology and other ways, in fact, ultimately. So Unix sockets or something else and all that, because based on that, all the structures addresses will vary. So based on the length of that also, it is going to identify. So this is also important. So you have initialized all these structures. And then this is actually the client program, what we are actually looking at. So after initializing all this, simply connect. Make a call onto connect system call. Connect of sockfd, comma, address of the structure, comma, length of that. And then whenever it fails, it returns -1. And once this is over, like communication is there. Communication is possible by using read and write kind of entity. And then you are printing that whatever. I think all of you have followed this. It is the second program. This is the server program. You have to declare all the header files as usual. Here, you have to declare the file descriptors for server socket as well as client socket. Server socket file descriptor is useful for waiting for connections from the client. Waiting for connections from the client. That this file descriptor cannot be used for communication purpose. It is used only for establishing new connections. Whereas client sock FD is used for communication purpose between client and server. This is the one that actually talks about reading and writing data. This is the one that is going to wait for new connections from the client. Corresponding length variables you are declaring. And then you have to declare address structures for client as well as server. So you are specifying struct, sock, AGDRU and all that. And then as we said, the file name should not be there at the time of running the socket program. So you are removing that particular file in case it is there. So you say unlink of server socket. And then you are making a call onto socket of AF Unix sock stream 0. You get the server sock FD. Fill the server socket address. Right? So you are filling all those things. Server address dot SCN family AF Unix, str CPU of SCN path server socket, length of that, and then what? Bind. Bind the server to a known address. Bind the server to a known address. The address is already filled into the structures. So now bind of server sock FD, ampersand server address and server length. After this, after binding, you have to establish a queue for receiving the connection. Establishing the queue is listen of server sock FD, 5. Once the listen is over, now you are ready to wait for the connection request from clients. So because server must continuously serve the clients, so you require a loop, a while loop, a forever loop kind of it. So while one. So you want to serve the client request forever. So you say while one. And then printf server is waiting, just debugging purposes. And then client now. So client length is you say size of client address. Now accept of. Accept is a blocking system call. It's going to wait until a request comes. So accept of server sock FD, address of the client address, right? The address of the client is going to be filled by the accept after receiving the client request as a part of it. If you want to know what is the address from where this request is coming, you can examine this client address structure. And then because the corresponding length field also is going to be filled by the accept. So you say ampersand client length. Ampersand client length. And this accept returns the actual file descriptor. And that is client sock FD. You can use now client sock FD file descriptor for communication purpose. So you say read from the client sock FD and write onto client sock FD. This is actual like communication area, right? So this is how it is. Now you can run the program by running /server1, run it in the background. The server program must be continuously running. So you run it in the background. And then immediately after running that, if you examine the ls-l kind of it, you will see the file being created. This file is created once you run the client server program, because server program is creating the socket, and that's going to be there. Server socket is there as a part of it. And if you examine the first character in the ls-l, the S now. S stands for socket. D stands for directory. Right? B for block device, like that. Right? So it is a server socket. You can see that it is a socket related file. And you can see the PS to see what are the programs that are running currently. It is a /server1 that is currently running there as a part of it. Now you can run the client program. So /client1. So what client is doing? It is sending the character A. It is sending the character A to the server. What server is doing? It is increasing the capital A by one value so that capital A becomes capital B. And after increasing it, the server is responding or replying the response back by sending the increased character. So that B is going to be replied back to client. And the client will read that and print it. So that's why character from server is capital B. You can run that client program any number of times, or maybe in the background also and all that, right? So they will all be running as. So that's what is being tried. /client1 ampersand, run it in the background, run one more in the background, run one more in the background. 3 programs are running in the background. So you will see 3 outputs naturally here. They will all come from what? From the server. The same reply kind of thing. If you want, we can change the program so that a different character can be sent to the server and different result will come. So what is learned in this particular 2 programs is how to establish connections between the client and server, and how to read simple data. So that is actually established, right? That is actually established. Now let us take a look into the corresponding programs. Because the programs are there in this thing. I have actually already made a copy of those things so that we can try. We can make changes to that if required. All that is possible. Okay, so this is a client program, what is actually discussed, right? Client program, because of which you are using the connect and all that, right? So I have made all the necessary changes, especially those double quotes, single quotes. Whenever you copy paste, you get some errors. You have to replace appropriately and all that, right? So we have already discussed that particular thing. This is the client program, and this one is the server program, right? This one is the server program. So make an effort. So you also have the corresponding PDF file, copy paste onto a Linux machine, and then try to run it. So how do we run this particular thing? We require this thing. Do we have it? We have it, right. So this is the place where it can be experimented now. Uh, so how are you going to run it? /server1 server1 and run it in the background. Run it in the background. No such file or directory. Yes. So maybe it's not there. Like we will have to compile it if it is not there as a part of it. Let us take a look into this. Server 1 is not there. Client 1 also is not there. C programs are there, but we have to compile it. All right. So let us compile it. So this is the one. Now we would like to copy it actually. So or move whatever. Server 1 as such. This is done. So GSS. The other one is client. Because for me, character C problem is there, as you are already familiar. Client 1 dot. You can say C as default. So this is done. Client 1. Now I can come back to this. Okay, so now we can run the server program and all that. Server 1, run it in the background. Run it in the background. So server is waiting. All right. So you can also see here PS as a part of it. Server 1 is running, as you can see. If you want, we can take a look into a long listing of that particular thing. So /server1. These are the details about whatever. So essentially, server is running. We know that. Now you can also take a look into ls-l kind of it, or just simply ls also. In which case you can see that server socket must be running, must be there. This is a server socket file. And it is also colored. If we want that file type and all that, in case we want, we'll have to give a maybe -L and a capital F. If we want, we can always give it. Now you can see this is actual server socket. Equals is going to be there because of that particular thing. So I have also run some other programs where other server sockets are also there. Date server, SQL, Square server, like that. I have tested actually. We can look into that later. So those are all socket files. Socket files. Their length is 0 and other things as a part of it. Now we will like to test it by running client program. Client program, we can test it. Client 1. You see, server is waiting and it is connected to this client, and the output from the client program is character from server is B. You run it any number of times, you get the same output basically, because the server is there. If you stop the server and try to run this, you get the error naturally. You get the error naturally as a part of it. We can see even that also. So how do you stop this particular uh, what it is, the corresponding thing? So you require the process ID, or the other one is by what it is dot slash server one. This is the actual thing. So you can kill that particular thing. So that is killed now. And if you take a look into the this particular thing, server socket is still there, as you can see. Server socket is still there as a part of that. So now, if you try to run the client program, but we have stopped the server program. You see here, connection refused. You get this, right? Because we have also written the program here. Now you can take a look into client program. So after connect, you are getting the result. And if the result is -1, this is a 1. Oops, client 1, and then appropriate message. This message you are getting because of this particular thing. Because you said like server socket and you are trying to connect to that. And whenever you are trying to connect to that, the server program must be running. Only then it can actually connect to that particular server program. Even if this particular file is there, right, you are not going to succeed in connecting to that particular server, right? Any questions at this stage? I'm just blindly teaching.
No, sir.
All right. So now what we will do is, you know now like about how to actually connect, how to establish connection, how to write client server, client program, server program, and all that. All the basics are the same. Now you can make changes to what? Changes to the protocol, application protocol, we call it, right? This is only single character you are sending. Instead of that, we can actually, let us see, for example, there is something called a time server or date time server or whatever. See, what we want to do is, whenever client connects to one server, that server should return the current date and time. It should return the current date and time. So you want to know what is the current date and time, exact date and time. So what you can do normally, you can maintain one system worldwide, something like that. Maintain the date and time properly on that machine, and all the other clients can connect to that and find out what is the current date, correct date and all that, right? For that now, let me show you uh, the corresponding programs here. How to write the corresponding thing. Date server and date client. So these are the things. So this is date client, what is actually developed. Similarly, you require a date server. This is the date server. Let us look into both of them. So whether we can follow it or not. So all the required thing, except that now you also require a logic for finding out what is the current date and time. You require appropriate library functions or system calls by which you can get to know. You can get to know the corresponding date and time and all that. So apart from keeping all the header files required for network programming, date and time, if in case you want, you require time.h. Time.h header file must be included. And then some kind of string processing functions may be there for them. String.h also you require. Other header files are already there. Now declarations, right? As you can see, the same declarations you find. This is a date server now. What we are now examining is the date server. So unlink what? So now you require a different file name, right? Because it is a different server, or like path name or whatever. So earlier just simply server socket or something we said. Now we are calling it as date server, name of that. So you first remove it, unlink of that. And then server sock FD, you are making a call onto that. All these things will not change. Only this particular file name will change, date server. And then you bind it, listen on that while one. Now, because of the logic being different, you declare appropriate variables. You declare appropriate variables. So this is the forever server, right? Forever loop. Now you require the variables for handling the date and time. So these are the variables. Character star date str, date string. Date str is date string pointer. We have some library functions that will return the current date and time. To get that, you are actually declaring this variable. Similarly, to know what is the current time and all that, because time is always measured in terms of how many seconds are completed or elapsed after a certain reference point. And that reference point is 1970 January 1st, actually. So you have one of the system call by which you can get to know how many seconds are passed from that particular thing. So for that you require an integer variable. This is actually integer only, except that, so for different purposes, the integer type is named with different things. So this is time underscore t, followed by t is a variable. We will get the number of seconds elapsed into this particular variable called t. Server waiting as usual, right? And then client length, client address structure length, you have to find out. And then accept. So this accept is the one where you are waiting for the connection. All these things are the same, as you can see. Now you have to find out what is the time. And to do that, you call this particular thing, time of ampersand t. So this time system call will fill the variable t with the number of seconds elapsed from 1970 January 1st. But how many seconds are elapsed from there is of no use for us, right? It's going to be a very big number because every day 86,400 seconds are there. So that multiplied by depending upon how many days. So such a big number you are going to get, representing a particular date and time. So we have to convert that number into human readable date and time, this thing. For that, you have another function called C time. C stands for character. So converting time into character format. So C time of, this C time requires the number of seconds elapsed actually. So that's why you are passing on that address of the variable called t, ampersand t. And this C time returns a character pointer. It returns the string. So that's why your date str is equal to C time of ampersand t. So now your date is there in a human readable format in the variable date str. Right? And that now what? Because now you are running the server now must reply to the client. Client doesn't ask anything. Client only connects to the server. The very fact that the client is connecting to the date server is only to know the date and time. So it doesn't send any characters, nothing, no request, nothing. Only connection request is there. So that's why the server will straight away write the reply back to the client without reading anything. Similarly, the client program corresponding to this date server will only read the data from, read the reply from server. So now, as you can see here, you are using straight away write here, right? You are writing it onto what? Onto client sock FD. Client sock FD is this. At the end of the accept, you have the socket descriptor. So that one. What is to be written onto that? Date string, date str. How many characters are to be written? Whatever is the length of this particular date str, you have to send. So strlen of date str. We are writing onto that. After doing that, because the job is over, so you close the connect. Again you go back. Again you wait. If there is another request, another service. So like this, depending upon the purpose of the server and the client, you can develop the different logic there in order to serve some purpose. So this is how you can actually do that, right? I think you are following. Now the client program, you can take a look into. What should be written into the client program? Client program need not know how to find out date, time, and all that. That logic won't be here. Only here, client program should know about what is the server, date server related thing. So only that much. So include all the header files, declare all the important variables. Now, date string, you would like to capture that, right? So you like to capture the date string. So you want to capture means what? You require an array where you can store all the incoming data coming from the server. So as you can see, character date str, but here you are declaring with 100 characters array. Whereas there you have not declared that as an array, it is a pointer because the C time actually allocates the required space for storing the string and it is returning the starting address of that particular thing. So that's why we have specified that as a pointer there. Whereas here, the client program should receive the data and store it into your own local variable. So you require an array here, naturally. So date str of, it doesn't require actually 100 bytes. Actually, it is returning 26 character, something like that. C time always, it is a fixed length thing. So no matter which date it is, it's always going to be a fixed length. So date str of 26 also might be okay. But to be safe, I have declared this as 100 there. The other things are same, right? Creating the socket, filling that with the appropriate path address, and then connecting to the corresponding server. And then in case it is -1, display this as an error message and all that. At the end of that, as you can see, what? You have to actually read the data from the socket. So read off socket file descriptor, comma. Read into what? Into the array date str array. A maximum of 100 characters you read. You are specifying. If you don't have 100 characters, you have less than that, it's going to read even that. But you are only specifying not more than 100 characters because the array length is 100 here. That's why you have specified that as 100. So at the end of the read, what are you going to get? Read also returns the number of characters that are read. So that is going to be available in LEL. Right? Now you can actually print. There are different ways, as you can see. Here, the logic, we'll have to actually put it. We'll have to put this particular thing. So you have actually read all that. The best possible logic is actually, you don't require a printf and all that. You can make this as a, what it is, comment kind of it. And then display it onto the screen, right? We have to display it onto the screen. So how do you do that? By using the write system call. Write off, one means what? Onto the standard output. What is the data that is to be written? The value that is there in the array, date str. How many characters from there? As many characters as you have actually read. So you specify LEL. This itself will do, actually. This itself will do it. But it's okay, right? You are going to get this particular thing, no doubt about it. Let us, this part we have commented. You are reading from there and then you are writing onto the screen and you are closing it. Right? So I think you are following now. Just simply save it. And now let's go back to this particular place and compile and run, right? That's what we'll have to do it. So as far as the server is concerned, dateserve.c. Again, same problem. So this is compiled properly. Now we'll have to move it, right? Move followed by a.out to dateserve. date serve as a part. This will do it. The other one is date client. The date client, this character C problem. Date client is there. Date server or date server. Date client, date server. So date server we have done. Now date client we have to compile it. So GSS date followed by C problem. I cannot type it. LIENT dot question mark. Right. So this is also done. Now you'll have to copy it. Move A dot out to date. So now it's a problem. So how to, you have to give a date client. Date CLIENT. CLIENT. I think they should do it, most likely. Date server is not a directory. Okay. Okay, let me initiate this. Okay. Date client. Now we have to run the date server. Date server. Run it in the background so that, so it is running now. Server is waiting there and all that. Now whenever you want to know what is the time and all that, so you run the date client. See here, server is waiting, and then you are getting this Tuesday, all that. You again run it, you get the different time, 9:28, 34, and all that. So this is how you can do that, in fact. But I want to display, if you just pay attention, this is the output, Tuesday and all that. But I want to display like the date or the current date is or something like that. So that kind of thing. There is another important thing that we'll be talking about here. See here. So not only the output of that you want to have date from server is equal to, like that we want to display. Date from server is equal to, you want to display like that. Okay, one way is, as you can see, here itself, you can say percentage yes, right? And then a new line, and then a new line. Because this is a string, you specify date str, right? Date str like this. And then this entire thing you don't require, right? This write and all that. We can as well say printf of date from server is equal to percentage yes, date str in this particular manner. As many number of cap, because like you are assuming that date str has got a null character at the end as a part of it, right? I think we should be able to try this particular thing. So we are actually trying different versions, how things will work. So you are actually learning C language directly as a part of it. So you have to experiment all that. So as you can see now, date from server equal to percentages, date str, you are specifying. And then you compile it again. You compile, recompile again, this particular thing. Oh. All right. So we'll say GSS. It's a client program that requires compilation because we have modified the client. CSS client dot. Then move A dot out to date client. All right. Still, the server program is still running. You are modifying only the client here, and you try to connect to that particular thing. Dot slash date followed by time. As you can see, if you pay attention to this, what are you getting? Date from server is equal to like that, and then Tuesday and all that. You are getting correctly only. If you also observe closely, you're seeing something junk here, some question mark, something, and all that. You run it again, you get another date and time, no problem. But this, because as we know now, you are only as if you pay attention to this particular thing. So what is being replied from the server? You are replying write off client sock fd comma date str. You are writing the contents of the date str starting from that particular address or whatever. How many characters? As many characters as the length of the string. Length of the string means what? It's going to write only up to what it is, the last character within the date and time, but not including the null value. Null character is not being written onto the what? Onto the channel. So the client doesn't receive the null character actually. So there is some junk at the end of the date. So that junk also is going to be displayed because printf will keep displaying until a null character comes. So all that junk also you are actually getting that. So if you actually, what it is, write here one more character, then it's going to write even the null character as a part of the reply. Then even if you use the printf, it's going to be okay as a part of it. The other solution is if you use a write system call, then you can specify how many are to be written, as many characters that are received. Then no problem, because it's not going to write the remaining things. Either you can use a write system call and give exact number of characters to be written. You won't get junk characters. Or you can use printf by ending the date string with appropriate null character. Right, one of them. If you don't properly end there, you will get some junk characters. So by just specifying +1 here, null character can be set. Then no problem. Or the other way is here you can actually use what it is because as you know now len. So here itself you can also do that. In fact, for example, date str of right len is equal to null value. If you can do this, then you are ending the corresponding date string with a null character also. So you are reading from that particular place. You are reading only exact number of date characters without the null character. That's why you are now putting that at the end of that. Then no problem. This is another way of looking at it. But let us save it, right? And then coming back to this particular thing, you have to compile it, and again move this. Now you run this particular thing. Now you see, you don't see any junk characters being displayed. So you get exactly the same thing as a part of that particular entity. So why are we getting two new lines there? Probably because one new line is already there. So apart from that, you are also putting one more new line as a part of what? As a part of printf. So new line character is already there in the date string. So that's why you can as well put in this particular manner if you don't want unwanted thing there as a part of that. So then you can just simply do like this, and then run this particular thing. See now? So server is writing, date from server is so and so, and a single immediately a dollar prompt being displayed. So like this, you can actually develop different server programs and different client programs. Different client program. Any questions?
No, sir.
So if this is okay, then let's move on to another interesting server, which is called as a square server. What the client will do is it will send a number to the server, and the server must find out what is the square of that and return the reply. Right? In this case, the client is not making any client is not sending any data to the server in the date server, but server is doing some job and then giving a big response. So in the next case, we will actually send a number, not a character kind of thing, and then examine how we can actually do that and all that. So that is another case scenario as a part of that. So a slight modification again to the same essential things. So you open, for example, Square server and Square client, right? So this is a Square client, and Square server, Square server, Square server.c. These are the two programs. You should try with different application protocols. These are called as application protocols. Simple small application. Okay. So this is the client here. So as usual, declare all the header files, declare the address structures and all that. And as you can see, the path name is a different one. You say SQR server, Square server as a part of it. Simply connect to that. If it is failed, you display the error message. Otherwise, what the client program here is doing is, client program will read a number from the user. The user is going to enter a number to the client, and that number is going to be sent by the client to the server. Client itself doesn't actually find out what is the square of that and give you the reply. Instead, it is sending the number to the server. The server will receive that, find out the square of it, and give the reply back to that. Client will read the reply and display this. So that's what it is. As you can see now, printf, enter a number. This is a client program, square this thing. So you're reading it, scanf %t ampersand. After reading, what are you doing? Now you have to send this particular data that is there in the variable n. Right? So you say now write off sock fd, and then what? Starting address of that particular variable. It is an integer variable, as you know. All along we are using character pointers. But now you are saying ampersand n. But how many bytes of data you have to send it? As many bytes as the integer occupies. If integer occupies 2 bytes, you have to send 2 bytes to the server. So if it is integer occupies 4 bytes, you have to send 4 bytes to the server. So ampersand n followed by size of n. So you are sending the number n in the bit form, zeros and ones, whatever, are there in all those number of bytes, 2 bytes or 4 bytes, depending upon your integer declaration. So the moment you write it onto the socket, it is going to be received by the server at the other end. Server will find out the square of that and give the reply back. Now you have to now get back to that. Either you can get back into the same variable, or you can get back into another variable also, no issue. If you get back into the same variable, then the old value is lost. If you get back into another variable, like both of them will be there. Okay, so let us actually do probably 2 different variables also. Either way you can do. You don't have to use the different variables there and all that. So for example, a square of the number, we'll say Sn, right? Sn as a part of it. Now you are writing the contents of n onto the network, and you are getting back into Sn. This way also you can actually do it. Ampersand Sn, size of, it's not a size of followed by either you can specify the data type or you can specify the variable of a particular data type. Size of n or size of Sn, both are one and the same because both belong to the same integer data type. Now, whenever you are actually displaying the results and all that, square of square from server. Okay, so from server we will see later on. Square of, so we'll use of here. Square of percentage D is another percentage D. Square of so and so is so and so. This what you are getting from the server. From the server. Like this. And then a new line, whatever. Square of n and square of n. Just n, whatever. So like this, we can always make changes, whatever is required. I think you understand now. We can pass any kind of data on the network. You can even declare a kind of a structure and fill the structure with all the appropriate values. And here you can just simply say write off socket FD comma address of that particular structure. And as many bytes as the size of that particular structure. And so on. You should experiment all these things, right? Only then you will learn about developing real world applications and all that particular thing. So this is a client now. This is the client program. Server program, if you just take a look into, declare all the header files required, whatever are there required, and then all this. Probably time.h is not required now, definitely. But even if you include some extra header files, no issue. And here unlink of square server, and then address is filled with SQR server, while one forever kind of thing. Server waiting, client accept this particular thing. At the end of accept, now this is ready. This socket can be used for communication purpose. And we know now that the client is sending a number. So here you are declaring integer n. Now here read of client sock FD comma ampersand n comma size of n. See, now both of them should know what is being sent and what is being received. Client and server must know the actual protocol, how the client will ask the server, how the server will give the reply back. So this must be known, and that is what is called as the application protocol. So application protocol will define the rules by which client and server can communicate. So server already knows that a number is coming from the client, and you have to give a square of that particular thing. So like that. So integer n, read of client sock FD, ampersand and size of n. And then find out the square of that. N is equal to n into n. And then give the reply back. Write of client sock FD, comma, ampersand and comma, size of n. And then all. There may not be any real world application for this kind of thing, finding square. You can as well, within the client itself, you can. But this is an example of sending different types of data between client and server. If the server has got some database where a lot of data is there, a kind of ID is sent from the client, and the server can extract that particular data from the database of a particular ID and give the reply back, right? All that. So you can think of any number of different scenarios, right? So we have done in this particular manner. You go back now and then try to run this particular program. So this is square here now, right? Square means let us now compile both CSS followed by square server, square server dot c. Minus o square, right, like this. This is compiled now. Similarly, square client program is to be compiled. Square. This is also compiled. Now you run this dot slash square cell. Square cell. Run it in the background so that it's going to be there. It's running. You can see all that by examining PS or appropriate right server sockets. Those are all created. Right? If you want to, we can see here ls minus L, and then sort it, right? Sort it, and then see first hyphen is there. At the end, you find all the sockets here. All the sockets. Server socket is created because of the original program. Date server is created, and then SQR server is created. All of them are running here. Now we have to run the what? Square client, where you will read a number and then send it to enter a number or any number, like 8 is a number. Square of 8 is 64, that you are getting from the server. Right? Naturally, you are doing this. So this you can run any number of times. 56. Or if you want the client to continuously read a number, get it from there. So you can design your logic in any way for that matter. But it will work only when the server is running. By any chance you actually remove that, naturally you should get the this is where cell, right? Right. Now we will try to do this. We will get connection refused. So like this, you have to extend your knowledge, and you can learn everything only when you write programs in this particular manner. Test them. Like you might fail, but see that you take appropriate corrections to the programs and all that, right? So then slowly you can improve upon that. So the next level for programming is your network sockets or IP sockets, right? Whereby we have to continue on the following thing. So, and if you're, this is the Unix sockets and all that. This is the address structure for internet sockets or IP sockets. Address structure for this particular thing. Struct sock HDR underscore IN. IN stands for internet. As we already said in the last class, the first field of all these structures is always going to be short integer. And even here also, its first field is a short integer. Name of the field is SIN underscore family. Same thing for the Unix sockets. It is still shorted, but the name of the field is SUN underscore family. SUN. Whereas here it is SIN, internet. So the first one is like that. The other things will vary because addressing concept itself will change from technology to technology. In the case of Unix sockets, addressing is based on the name of the file names. Whereas in the case of the IP sockets, socket addresses or IP4 addresses, right? So it's a number basically expressed in terms of what I call quad, right? Dotted decimal notation. It is called dotted decimal notation. A number dot, a number dot, a number dot. So 192.68.1.10, something like that. But that entire number is actually, it's a number, a single number. Because 4 numbers are there, right? 4 bytes. It's a 4-byte number. That's why you are specifying here unsigned short int SIN underscore port. Second one is a port number. It is a 2-byte port number. Third one is actually is the IP address, but that is expressed in terms of another structure actually. Struct in ADDR, internet address. And this struct in ADDR is the corresponding structure is like this. Unfortunately, they made things so complex. They could have declared this as an integer here itself, but they have not done that for whatever reason. So this is another one, struct in ADDR, unsigned long int, yes underscore ADDR. This is the one actually that contains the IP address. It is a long integer, 4 bytes. That's why. Right? So we'll be using these structures and all that while developing IP-based client-server programs. So all of them are going to be one and the same, whatever that we have done earlier. For Unix sockets, you have listen, all that, accept is there. Now slowly, so flags or whatever, requesting connections, all that, and then socket communications. And sockets are there, network client. So this is the one. This is the second program, client 2 dots. Same program. Now if you see here, as a part of the header files, you have sys socket. Then because now you are using internet technologies, the header file is net.inet/in.h. Net internet/in.h. Internet headers. Similarly, ARPA/inet.h. These two header files talk about internet-based declarations. Right? They will all be there within this. Then while writing your program, this is a client program. Struct sock ADDR underscore. In the IP programs, it's going to be IN. You have to specify IN instead of UN. Right? Declaration will be like this. And then whenever you create a socket, socket of, now earlier it is AF Unix we said. Now it is socket of AF underscore INET. So the first parameter is different now. You are developing or you are creating a socket for IP based programs. So you say AF underscore INET. Using this, it is a connection oriented. So you say again sock string, comma 0. So socket of AF INET, comma socket stream, comma 0. Now you have to fill the address structure with appropriate values. Address structure with appropriate values. So now you say address dot SIN family is AF INET. Address family now is AF INET. And then the corresponding structure just now we have seen used to be filled. So address dot SIN underscore ADDR dot S underscore ADDR. This is the one that contains the address. So, like to develop a simple program so that on the same machine again, both client and server will run, even though you are developing for network. But when you have only one machine, this is how you test it. So, like your local, like what it is, local machine, whenever you want to run by using IP-based program, your local host address, this is called a local host address. 127.0.0.1 means that it is your machine, current machine on which you are running the program. Actually, this value used to be stored into the, but this is a number, right? This is an integer value. But you can't store a string into an integer. So you require some mechanism that is going to convert this string into a single integer. This string into a single integer. Because it is difficult for humans to calculate what is the number corresponding to this, right? And to remember that kind of numbers also, they have developed a small library functions. And this inet underscore ADDR, it is a library function that converts an IP address given in dotted decimal notation into an integer format. That's what it is doing. Inet underscore ADDR of specify the IP address. This IP address can be anything, not only local host, any other number also you give, it converts that into appropriate number, right? So this you should remember, very important step. This can be given in different forms also if you understand the actual logic of this and all that. This is nothing but actually 1 plus 0 plus 0 plus. This is actually 256 into kind of thing. 256 into 0 plus 256 square into 0 plus 256 cube into 127. That way also you should get actually. Anyhow, so this is a number now, but better you use library functions, get used to them. It's very important. And then you have to run these programs on one of the port numbers. And you have to specify a port number also here. Because whenever you are running network programs on networks, your server program that is running might provide many services. So this IP address will identify only the machine actually. It is identifying a specific machine. But inter-process communication means what? You have to identify a process, not a machine. So on that machine, which process? So on that machine, which process means? Now you will have to specify what it is, the port number. That port number will uniquely identify a process actually. So you say SIN underscore port equal to some number, 9734. It can be any number, except that this number must be known even to the client. Client should know both the IP address as well as the port number in order to connect to the server. So 9734. And then the length of that and all that. It is the same, whatever we have done for Unix socket. So that's why he stopped even. The remaining program is going to be the same. He did not even write that. Because once the connection is established, then reading and writing data is going to be same on the socket, basically. On the socket. So this is how it is. It is a client program. So the remaining connection establishment, everything will be the same. That's why straight away is going for /client2, trying to run that. So server program also you have to now develop. So again, include all the header files. And then for the server, you require two sockets, server socket FD, client socket FD. Corresponding address structures. Socket ADR in now, all that. So again, socket of AFINET, sock stream 0. Now you have to fill the structure with appropriate things. You can see here AFINET, INET ADDR, all that, same port number, and then now you are binding. You are naming the socket with an appropriate address. Bind off this entire thing. After binding, you have to listen for that and all that. So the remaining program is going to be the same. What is changing from Unix sockets to like network sockets? Only the address structures are different. That's why up to that point, up to binding, the program is different. The remaining, like listening, accepting for that, all of that is going to be the same. All of that is going to be the same. And then when you run that particular thing, you will get certain output, whatever. We'll see the remaining things in the next class. With this background, you come to the next class with some preparation or doubts or whatever, and we'll continue the remaining things. We will also examine how it is and all that. Especially even when you want to test your network programs using IP based, you don't require a network in fact. In the sense, if it is there, it is wonderful. Because if you have two machines, they are connected, then you can run clearly server on another machine, client on one machine, and then do that. But you don't require that. That's the reason why we have used local host. We have used local host there, so that both of them will be running on the same machine. And but addresses and all are based on IP only. So the remaining things we will examine how to do that and all that. Right. So Thursday we will meet once again. Hoping that you are all following. So we will just stop the presentation and then stop recording.